Again, in this example, we are going to use ratio test. To find the radius and interval of convergence. So S sub n is -1 to power n x to power 2n over 2n factorial. And S sub n plus 1 will be equal to okay. I can actually simplify this to -1 to power n plus 1 x to power 2n plus 2 over 2n plus 2 factorial. That's much easier than the version above there. All right, so now we are going to plug this in the formula for ratio test. So x to power 2n plus 2 over 2n plus 2 factorial divided by what we have for s sub n, which is x to power 2n over 2n factorial. All right. What we'll end up with here is the first term. I'll leave it as it is, but I'm going to get the reciprocal of the other one. So I'll end up with now you can use indices to simplify these guys. Let me just rearrange them so that we can be able to handle this in a much easier way. So I'll bring these guys to the left. So what I'll end up with is 2n factorial over, I can expand this denominator to have 2n plus 2 multiplied by 2n plus 1 multiplied by 2n factorial multiplied by x. And for this second term, I can just simplify it using indices. So this cancels out. So I'll end up with the limit as n approaches infinity of this will simplify to x squared over 2n plus 2 multiplied by 2n plus 1. And I can factor out the absolute value of x squared. To end up with 1 over 2n plus 2 multiplied by 2n plus 1. So I'll end up with 0. So absolute value of x squared multiplied by 0, which is just equal to 0. So I'll end up with, you know, this is 0, so we have 0 is less than 1. for convergent for ratio test, we know that when our limit is less than 1, then the series converges for all values of x. So, I mean, from our calculations, we've ended up with the left part of the ratio test being equal to 0, and therefore we can conclude, because 0 is less than 1, we can end up with we can make a conclusion that this series converges for all values of x. So what I'll do is I'll just add a statement here and say, maybe this will make more sense. When you plug in any value of x, this series converges. Okay? Any number multiplied by 0 and 0. All right? And this is because 0 is less than 1, which is a condition for convergence for the ratio test. All right? So we can make our conclusion and say that hence the interval of convergence is negative infinity to infinity, and radius of convergence is infinity. All right. Example 5. Find the radius and the interval of convergence. Same drill. So use ratio test. So S sub n is all right. So plug this in the formula for ratio test. If you simplify this, you'll end up with just use indices. And at this stage, what we can do is we can factorize out absolute value of x. At this stage, use LHR, L'Hopital's rule, which means that limit will be equal to 1. So we'll end up with just this will be equal to absolute value of x. All right. So what next? We know that a series, power series, converges if actually from ratio test, we know that a series converges if the limit of the absolute value of S sub n plus 1 divided by S sub n is less than 1. So you're going to write this down and say so we know that it converges if whatever we ended up with, which is absolute value of x, is less than 1. All right. This is from ratio test. All right. This is from ratio test. Remember, we used the ratio test from the beginning. All right. From ratio test, if it converges, then that should be true. And you're going to use that to find the interval of convergence, so which means this can be written as negative x, sorry, not really negative, negative 1. Okay, and we have to check the endpoints. Check the endpoints. Because sometimes they may or may not converge. We've discussed this previously. So at x is equals to negative 1, our series will be given by that, right? Remember, if you plug negative 1 in place of x, you end up with this. This is an alternating series which converges by alternating series test. So okay, so that converges by alternating series test, which means this point is inclusive. And at x is equals to 1, our series is plug 1 in place of n, so you'll just have 1 to the power n over n, which is simply 1 over n. And this is a harmonic series, right? We know that this diverges by p series test. Okay, so we can make our conclusion and say, based on that, the interval of convergence is from negative 1 to 1. And radius of convergence will just be equal to 1.